Today we're going to talk about Taylor polynomials. We're going to walk you through what it is and how you construct it. A Taylor polynomial is a way of making large and complex functions simpler in order to get an approximate value of the function. The higher the degree of a Taylor polynomial, the more accurate the approximation.
Okay, so as you can see, the formula for the Taylor polynomial is basically f times a plus first derivative of f of a divided by 1 factorial times x minus a to the power of 1 plus f second derivative of a divided by 2 factorial times x minus a to the power of 2 plus f third derivative of a divided by 3 factorial times x minus a to the power of to the cubic root. So here this is the formula, but the general formula is all this plus f to the power of n divided by n factorial f to the power of n times a, times x minus a to the power of n. Now we're going to start to solve our equation. So basically our equation is f of x equals 4x to the power of 3 plus 5x to the second power plus 8x plus 6, and it's centered at 0. So first we're going to get the first, second, third, and fourth derivative. First derivative would be 12x to the second plus 10x plus 8. The second derivative would be 24x plus 10. The third derivative would be over here 24x, 24, so only 24. The fourth derivative would be 0. Now we need to plug in our center point, so f of 0 in each of these equations. F first derivative of 0 equals 12 times 0 plus 10 times 0 plus 8, so 8. Second derivative will be 24 times 0 plus 10, 10. Third derivative will be 24, 24. And obviously the last derivative, fourth derivative, will be 0. Now we need to include our original equation and plug in our point, which is 0. So our original equation, which is f of a, would equal 4 times 0 cubed plus 5 times 0 squared plus 8 times 0 plus 6. So f of a would equal 6.
Okay, so the final step to solve this third degree polynomial is to put these derivatives into this function. So it's going to be f of a, which is 6, so 6 plus f prime of a, so the first derivative of a, times x minus a divided by the first factorial, which is going to be the first derivative of a is 8, so 8 times x minus a in this case is 0, so x minus 0 divided by 1 factorial. Then we do that plus the second derivative, which is 10 of a, times x minus a to the second power divided by 2 factorial. So it's going to be 10 times x minus a, in this case 0 again, to the second power divided by 2 factorial. Then we're going to do the same with the third degree derivative. So it's going to be 24 times x minus a, which is 0, to the third degree, third power, divided by 3 factorial. And then the final step plus the 4th degree derivative, which is 0. So 0 times x minus 0 to the 4th power divided by 4 factorial. This is gonna cancel out, so I can already cross this out. Then we're gonna have 6 plus 8x. This is to the first power, by the way. 8x divided by 1 plus 10x squared divided by 2 times 1 because it's 2 factorial, and then plus 24x cubed divided by 3 factorial, which is 3 times 2 times 1. Then finally we're going to have 6 plus 8x plus 10x squared divided by 2 times 1, which is 5x squared, plus 24x cubed divided by 3 times 2 times 1, which is 6, and 24 divided by 6 is 4. So you will have 4x cubed plus 4x cubed. And this is your final answer.